Okay, until now, we've pretty much followed a somewhat structured step-by-step process to work our way through univariate, bivariate analyses of our various feature and label attributes. So now we want to start looking at adding maybe some additional dimensions to our analysis. And here we start to get to the point where we can start exploring a little bit more freeform, a little more creativity in the process. So what we may start to do here is start thinking of ways that these effects work with each other or compound with each other. Are they independent of each other? Do they just kind of stack? Just how do they work together? All right. So let's go ahead and start. Let's say I've got a scatter on age here. So this is one we looked at earlier, and it looked kind of funky. I'm going to go ahead and duplicate this tab. And we're going to call this "3D" or ND, n-dimensional age and charges. All right, so we've got our three interesting looking bands here. Is there something going on with each band? We've got our trend lines, so we know that the bulk of those data points are down there in that bottom mass of data points. All right, so we've got this is kind of our anchor for the diagram. Then we have a couple bands up here that are also spread out, but still form distinctive lines that seem to take just about the same shape as the line below, which I believe does have a little bit of a curve on it. We ended up having a power line, I believe. Yeah. All right, so let's see if we can bring in some other ads. So we've got age and charges. What if we brought in sex? And we can make that color. All right, so I bring in that and don't really see a whole lot of difference. So that I'm going to basically conclude that sex is not a big differentiating factor here in those bands. Smoker is our other categorical variable that seemed to have a pretty big t-test effect. Let's check that out in here. Okay, yeah, and we can see that smoker adds a really distinctive break between these two bands. So in the bottom, in the blue, the non-smokers that we can see over there from our legend, we've got the larger mass down there in the lower costs, and then a scattering of higher cost non-smokers in the blue dots. Now, in that middle band, we also have a scattering of the orange smoker dots. But remember, we have quite a few fewer smokers than we had non-smokers. So that actually looks like it could be the mass, although as I go up and look at the higher smokers, that other band up top, and then a few real scattered outliers way up there, maybe not so much of an anchor band for the smokers. And as you see, that trend line actually tends to kind of split the middle between those two groupings. So yeah, maybe they are more evenly split, whereas you can tell the trend line for non-smokers moves even more down into that base massive data points. So yeah, most of the mid-band, or at least a good chunk of the mid-band, is made up of smokers, meaning much lower percentage of non-smokers is in that middle band. And then that upper band is pretty much all smokers. All right, so that's interesting. We want to keep this one, and we will copy and paste this into our data understanding report so that we can report on this finding and say this is something where we may want to consider an interaction effect variable or an interaction variable where we multiply smoker as a dummy variable, 1, 0, and age to come up with yet another predictor variable. All right, so we'll leave that. Well, let's try a couple other things. So when I use category, I can use color, place that in the color to differentiate between color. That's not going to work quite as well unless I'll try it with children, and that might work just because we have a pretty small number of colors or of children. But I look at that and it gave me the blue thing. Yeah, even though it's probably not a good idea to have a diverging scale here, I'm just going to, unless there's one, yeah, that's a temperature diverging. All right, we'll just try that and see what happens. All right, so that gives us a little bit more, but yeah, green seems to be everywhere. Yellow seems to be everywhere. Yeah, so I don't know that children is really helping us out that much. For other ones, I'll put like, let's see, body mass in size here. And what that's going to do is going to change the size of the various bubbles or dots on here. And I'll see if I can make that even more. That may be a little too much. Yeah, let's see if we can add a little bit more of a dramatic difference to these. So yeah, I don't know that I'm seeing anything jump out at me with body mass. So I think, let's see, what else do we have? Charges, children. All right, so that leaves us pretty much with smoker in colors. And now I have to change my dots back to their original size. Yeah, that's good. All right, so we would keep that scatter and put that in our report. Let's see what else we have. All right, so scatter, age, and charges. All right, so BMI, this is one where we ended up having a polynomial describe it, going up to cubes. And if we look at this distribution, we've got kind of the bulk or the foundation right here. And then that foundation, if we look at our trend line, well, the trend line starts up here. And so it kind of is going, if you try and make it a little more linear in an easterly direction, let's call it that. But we have this other flare going up this way. So again, let's try bringing in some other measures to see what's going on. We'll start off with region. Okay, that doesn't seem to do anything. We didn't try region in the other one, so we might bring that back in. And I also forgot to duplicate that, so I want to keep my original scatter, but I'm going to go ahead and duplicate this, drag it to the end, and we'll call that BMI, or no, n-dimensional BMI charges. All right. So while I'm thinking about it, I'm going to go ahead and take smoker back out of this for a minute, throw in region to see if that gives us anything. And no, all the regions, there's a slight difference in the slope of the lines, but they all seem to have a similar magnitude and similar direction. So again, I'll take region back out and throw smoker back in, and that's the one we'll keep for that one. All right, so let's try BMI charges. Again, region, if we bring in color, yeah, that gives us an interesting starting point for these two regions here. But let's see, I don't, kind of the darker blue and the red, so northeast and southeast. All right, so, but I don't know that that looks like that's going to be a huge difference. And certainly looking at the actual scatter itself doesn't yield any particular patterns to me. All right, let's go to, we can do children again, I guess. Change the colors again. We'll use that temperature again. Yeah, so again, I'm not seeing anything there, and there are fewer people that have more children. All right, so let's pull that out. Sex. A little bit of a difference, but again, the data points seem to be scattered throughout with a mix of both. And then we'll bring in a smoker, our prime suspect, and that's for a good reason. It did have the highest t-test significance level and magnitude. So let's try that. Yeah, and sure enough, we can see that there's a distinct pattern and really almost a line there. Let's go ahead and change those trend lines to a linear. Yeah, so even though the fit's a little bit worse with the linear, this really illustrates a dramatic difference between the two. So non-smokers, yeah, there's certainly a slight increase based on body mass, but if you have body mass and you're a smoker, look at how dramatically that curve goes up as you age. And I would assume with age that might also be a proxy for the number of years you've smoked. All right, so we're definitely going to keep this one. And then we could take a look at the other scatters. We've looked at the scatter for BMI, and now we'd move on to children, etc. And you might want to even take a look at some of the histograms as well and bring in some other dimensions, some other attributes in here to see if you can see anything that helps you find some kind of a pattern that you suspect might help explain what we're seeing, and also what might help explain any type of algorithm that we developed to help predict our charges. All right, so I think you get an idea of how to start exploring here. So continue to explore your data set. Add additional dimensions, and you can even add more dimensions after you get that third one in there to see if you can find additional patterns that you think might be interesting. And when you do, you take that visualization, put it into your report, and write a brief explanation of what you've found and how that might be meaningful and what new attribute we might have to create, or how we may have to modify one of the existing attributes to be able to make that analysis. And we'll make that change in the data prep section, but you'll start recommending those changes in your data understanding section. All right, so that's it for this video. We'll let you get back to it and keep working on your project.